Hey there, water resources students. Back again for another lecture here. We're going to talk about the hydrologic cycle. So, you probably literally started learning about the hydrologic cycle or the water cycle back in grade school. So, this isn't necessarily anything new. What's probably a little different about the way I want you to think about it here is how we're going to categorize the different parts of the water cycle or the hydrologic cycle. Um, First of all, water is constantly in motion. That is what the water cycle or the hydrologic cycle is about. So we can categorize those motions as transfer processes. Those transfer processes move water from one place to another, and we can call those places sinks, S-I-N-K. In science parlance, a sink is some place where we store stuff, so a reservoir maybe. So if you look at the water cycle graphic that I have here, and there are 100 of these out there, there are probably 1,000 of these out there on the internet that you can download. Usually the arrows are going to be, take a guess, wait for it, the transfer processes, right? So we have an ocean. What's the ocean? The ocean is a reservoir, it's a sink. So water is stored in the ocean. And then one way that it can leave is through evaporation. Evaporation transfers that water to the atmosphere. We might store it in the atmosphere then for a while. Think a cloud. Although not all water vapor in the atmosphere is in clouds, a cloud would be an example of a place where water is being stored. So it could be a sink. And then we have other transfer processes like precipitation. That's how we get the water back out of the atmosphere. Some water escapes actually from volcanoes. So there's water that's been trapped down deep in the earth since the earth formed, when the solar system formed. And volcanoes, when they erupt, a fair amount of water comes out with that. That's water that's been down there for billions of years in some cases. So that is a sink, the water that's stored in the crust, and then when it erupts, that would be a transfer process. Groundwater flow would be a transfer process. Groundwater would be a storage place. All right, so I think you get the idea there. Let's talk a little bit about these transfer processes. This is not an exhaustive list, but these are some of the main important ones. Precipitation. I'm sure you know what that is, and we use the word precip because it could be rain, it could be snow, it could be sleet, any form of water falling out of the sky. Evapotranspiration. This is the combination of any water that gets evaporated or transpired. So right now when I'm talking and breathing, there's actually water vapor in my breath that comes out, so I'm transpiring. I drank water earlier, and right now, just sitting here, I'm talking and breathing and sweating and things like that. That's transpiration. Trees, vegetation, pretty much anything that's alive transpires. It's really hard scientifically to measure one of those relative to the other and to tell how much of the water vapor comes from evaporation versus transpiration. So we just lump it all together as evapotranspiration, or ET. And that's all the water that ends up getting moved from sinks on the land surface or the ocean surface back up into the atmosphere through one or the other process of evaporation or transpiration. We have infiltration. Infiltration is water moving into the soil. Percolation is that soil water moving deeper into groundwater. We'll talk about that in a second. And then runoff. Runoff is any water moving across the surface of the earth. So some sinks. We already alluded to some of these, like atmosphere, water bodies like the ocean or lakes, streams. So stream flow, the flowing water in a stream, I suppose, is a transfer process, but the stream itself, the river itself as a system, could be thought of as a sink. So there's a little gray area here sometimes. Glaciers, we don't have a glacier in the figure here, but a glacier is a place where water is being stored. Now, glaciers actually move and flow like really, really, really slow rivers. So once again, just like a stream, that flow, that glacial movement is a transfer process, but the glacier itself can be a sink. Soils, because water can infiltrate into the soil and stay there, that is a sink. And then groundwater is a place where actually we store a lot of fresh water on Earth. So now that we've talked about all these sinks, we can talk about our global water inventory. Where is all this water on Earth? Well, first of all, most water on Earth, as I'm sure you know, is in the ocean. And unfortunately, in terms of water resources, that's not very useful water to us. From a water resources perspective, we really can't drink that. I know there's desalination and so forth, but that's expensive. It's only used in a few specific places. For the most part, the ocean water is not something we're too concerned about in water resources. I'm not saying it's not important. Marine ecology, the oceans in general are important in other ways, but as a water resource, not so much. So about 96.5% of the water on Earth is in the oceans. There's a lot of water out there, folks. So that means the other 3.5% of the water on Earth is fresh water. Now about half of that fresh water, about half of that 3.5%, 1.75% or so, is tied up in ice caps and glaciers. Think Antarctica, think Greenland. This is water that's really not available to us over the short term. It's there, it's stored, but we can't really get at it. The ice is all tied up. I guess you could hook a boat up to a chunk of ice when it falls off of Greenland into the ocean and try to haul that back. But for the most part, that is a reservoir we can't tap. The other half of that 3.5%, so about 1.7% of the total water, or about half of our fresh water, is in groundwater. Now, if you look here, a lot of groundwater is actually saline, meaning it's salty. So only a portion, 0.76% of the total water on Earth is freshwater groundwater. 0.76% of the fresh water on Earth is fresh groundwater. Now, there's a tiny bit in soil moisture, tiny bit in ground ice and permafrost, a tiny bit in the lakes, a tiny bit in the atmosphere. I kind of find it hilarious that they list swamp water here versus other wetlands, I guess. I think we'd usually just call that wetlands, although not all wetlands would be classified as swamps. But anyway, there's a little bit in rivers, and then biological water is actually the water that's tied up in you, me, and all other living organisms. So what that means from a water resources standpoint, if we're talking about the water that's being used by humans, by ecosystems to thrive and survive, we're talking about groundwater for the most part, and we're talking about river water. And you can see those are, and lake water. These are really small amounts of water. So here's all the water on Earth. The green part is the oceans. Just this little 3.5% at the top, or two actually, because of the saline portion of the groundwater, only about 2.5% of all water is fresh. So this is just the same information as in the table, but broken out into a graphic slide here. But out of all that fresh water, most of that fresh water is in glaciers and ice caps, and then about a third of it is in groundwater, and about 1% in surface and other fresh water. If we take that surface and other fresh water, you can see we can break that out even more. So that's the water we can sort of get at and use. So that's the hydrologic cycle. Important points. We've got transfer processes. Those are represented generally by arrows on this and most other water cycle graphics. We've got reservoirs. Those are places where we store water. We didn't really talk about time frames. Some reservoirs, like glaciers or groundwater, could store water for tens of thousands of years. Other reservoirs might only store water very temporarily, like a couple of days or a couple of weeks. Atmospheric circulation moves water around the globe very quickly. Water vapor moves around in just a couple of weeks. Water in the oceans, deep ocean water gets tied up into the deep ocean for a long time. Water in the ocean that's a little closer to the surface, not so long. I'm not putting any numbers on this, partly because I don't know those numbers off the top of my head, but my point is, know that there are transfer processes, know that there are sinks, know that different sinks will store water for different amounts of time. And all of these things are important in terms of how humans and other animals can utilize these water resources for the things we need water for. All right, that concludes the lecture on the water cycle. Thank you.